Hello everyone. Today let's solve the problem number 1 to 7, word ladder. So what the question states here, we are given a begin word. You can clearly see here we are given a begin word and end word. So and a list of words called word list. You can clearly see here we are given a begin word, end word and the list of words called word list. You can clearly see here. What is our main goal then? Our main goal is to transform begin word into end word. We have to transform begin word, this one, into the end word by changing only one letter at a time. So we have to change only one letter at a time, such that they have given some requirements here. Every intermediate word in the transformation must exist in the word list. So they have clearly mentioned every intermediate word in the transformation must exist in the word list. Each adjacent letter in the sequence must differ by exactly one letter. This is very important. First requirement was for every intermediate word in the transformation must exist in the word list. So here hit next transformation has to be present in the word list. So hit here in this case, this one hot we have to consider dot. Either we can consider from these 6 words they have given in the word list. First thing. Second, each adjacent word in the sequence must differ by exactly one letter. Suppose here we are considering hit. Next we are considering hot here. So hot here you can clearly see I is replaced by O here in this case, right? Only one letter we have to change in the next word. That's what they have given in the second requirement, hot. If we consider hot dot here, D H is replaced by D. Only one letter is differing. Same goes for every other word in the word list. So second one was for every adjacent word in the sequence must differ by exactly one letter, this way. So third one is the transformation sequence should be the shortest possible. So here they have mentioned the transformation sequence should be the shortest possible. You can clearly see here hit. If we consider, first thing we have to check here is cog whether so if it is present, we will check whether the end word is present in the word list or not. This is the first step. They have also mentioned in the question that if end word is not in the this one, if end word, this one cog they have mentioned here, right? If end word is not present in the word list, in this case word list is this one, right? If end word is not present in the word list, then we have to return 0 because no transformation is possible at all. So we have to go from begin word to end word, checking for the shortest path, and the word has to differ. Every word has to differ exactly by one letter, right? So here if the end word itself is not present in the word list, then we have to return 0. Here let's come to the example 2. Here you can clearly see end word they have given cog here. So this is not present in the word list at all here. So the output we have to return 0 in this case. The output that we have to display here is 0. I hope this is clear. So let's consider this example. So here as per the question they have initially given hit, first end word. So first end word they have given here is cog, right? So first what we will do, we will check whether the end word is present in the word list or not. Here you can clearly see end word is present in the word list. So cog is present here, right, in the word list. So we'll move with the first step, begin word, hit. So let's check whether this one hot, it has to differ by one letter. Here O is replaced by I. I is replaced by O here. This is good actually in this case. So we'll check for this one. This is good. This satisfies the condition. Next condition we'll go with the same thing. D here H is replaced by D here. This satisfies the condition. Next here in this case T is replaced by G, one letter, right? This also satisfies the condition. Next is lot actually. Here dot and lot we will be checking here in this case. So here either it can be for the hot, it can be dot or lot. For the dog we will be checking for log or cog, right? So for the dog we can go with one letter. It may be here D. D is replaced by L, and either we can consider this one cog as well, because D is replaced by C. In this case, they have clearly mentioned in the explanation, one shortest transformation sequence is hit, hot, dot, dog, cog. Here in this case, hit is fine. Begin word hit is fine. That is 1 we will consider. Hot 2 we will consider. Dot 3. And when we come to 3 here, third one dot, either we can replace this one with lot, right? Lot, or yeah, just give me a second here. Yeah, we can just replace this one either by lot or dog. We will consider anyone. We can consider anyone. In this case, if we consider lot, then we cannot move to cog. So we will be considering dog in this case, right? So dog will be fourth one. That's what they have given here. Dog. So now we have DOG. We can either consider LOG or COG. We need the shortest transform that is possible. So here, we can go with cog or log. We will go with cog directly for the dog. So this will be the fifth letter. So that's what they have given here. One shortest transformation sequence is hit, hot, dot, dog, and cog, which is 5 words long. So the output that we need to display or we need to return here is 5, right? In this case, here in the second example, the end word, this one cog is not present in the word list at all. In that case, they have given in the question that we have to return 0 in that case, right? So I hope the question is completely clear. Initially, as usual, let's discuss the approach first, followed by this one, edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. For this one approach, I'll just consider the same example, first example that they have given here, right? So let's discuss the approach step by step here. The approach that we'll be going with here is BFS and the hash set here. You can clearly see, or we can just say BFS. Why we are going with the hash set? Because you can clearly see here every letter. So we have, first thing is we have to return the length of the sequence as the output, right? So every word in the sequence is different from one another, right? Hit, hot, everything, every word has to be different from one another. So that is the reason we will be making use of the hash set, and we are going level by level. In this case, we'll check hit and hot first, next hot and dot, next this one dot and dot, level by level, right? So for that purpose, we'll be making use of the DFS. So I mean, sorry, BFS. So for this for these kind of problems, it is better to go with the BFS, right? So this problem is particularly designed to solve with the BFS itself mainly. So let's I have considered the first example that they have given in the question, right? So let's see the step 1. So let's go step by step. So here what we will do initially, let's initialize the BFS queue and set. So this is for the initialization. I'll just give you, we will be initializing BFS queue and set here. So let me write here itself. So what we will do, we will create or we will initialize queue here, right? Queue initially, initial begin word we have here is hit. You can clearly see here. We have the word hit here, right? So we'll be going with the hit here. So this one, let's initialize this one with hit. This is word, and the first level, this is first one, right? So the level we will be considering this one as 1 here in the queue. So we are initializing, this is nothing but word, and this is nothing but level here in this case, right? So we are creating a queue with hit initial, this one begin word as word, and 1 we are displaying the level. We are going with the word and level, right? So I hope this is clear. Next, what we will do, we will convert the word list to the set here for the quick lookup. So now word list will be word set here for the quick lookup. So I have explained the same thing. So here we need we have to display this the length of the sequence here. So every word in the sequence has to be different from one another. That is the reason we'll be making use of the hash set I said. So that's what here you can clearly see every word differs here, right? Dog, this one, dot, hot, dot, dog, lot, log and cock. Every word differs by one letter, right? So we will be converting this one word list to the word set. So first what we will do, hot dot dog we have. So I'll just give here hot dot dog, same thing, dog here, and next letter lot, log and cock, log, and finally cock here. This is fine. We have converted the word list to word set, or to the set for the quick lookups, right? So the next thing is, if the end word is not in the word set, we have to return 0. As I have said, they have clearly mentioned in the question. But in our case, cog here, this is present as the end word. This is present in the word list, right? So here, so we don't have to return 0 in this case. So let's proceed further here. Let's move on to the step 2. Here what we will do in the step 2, we have to perform BFS. So we are going with the BFS, right? Let's perform BFS here. So I'm going step by step so that it will be very easier to understand, right? We will start BFS from the this one, begin word, or in the previous step we have considered hit, right? We will start the BFS from hit and try changing one letter at a time. So we will start the BFS from the word hit here. This is fine. And then we will try changing one letter at a time. So at the level 1, what happens here? Here, we have to process hit. So let's change hit with the hot. First word that is present here in the word list, hot, right? So we will change the word, this one, hit, to hot. Here, let's change level 1, hit, to, we are changing this one to hot, right? This is fine. First step, this is valid in the word set because hot is present. Now queue after processing hit will be, now queue will be hot as well as 2 is present here. This is fine. So the level here, this is nothing but word, this is nothing but level. Again, I'm telling just for the reference purpose. So first level was hit and the second level is hot. So Q, now this is changed into hot, right? This is for the level 1. So let's go for the level 2. Now we have to process hot. Now we are changing hot to dot. Either we can change here hot to dot. This is also valid in this case because only one letter we are changing here, D. D is replaced by H, right? H is replaced by D, sorry. Or we can change hot to lot here. So this is fine. We can change hot to dot, or we can change dot, this one, hot to lot. You can clearly see in the example here, hot, this one, dot is also present, lot is also present. Either we can go with the dot or lot, right? So in this case, this is also valid, this is also valid, right? So here now queue after processing hot will be, queue will be now this one, dot and lot, dot, this one will be level 3 and lot will also be level 3 because we have two words, right? So this will be for the level 2. This is what we get for the level 2. Queue queue after processing level 2 will be this one, dot and lot, right? So let's move on with the level 3 here. So level 3, we have to process dot and lot here. So next we have here is dot and lot, because sorry, not this one, this one. We have to process dot and lot. In the previous step, we are having dot at level 3 and lot at level 3. We have to process dot and lot here. So dot can be either dog or this one. Yeah, dot can be dog here in this case. This is valid because we are this one T is replaced by G here in this case, right? You can clearly see here. And for lot, this one we can change this one to log in this case. This is also valid because T is replaced by G here. In this case also T is replaced by G. And the queue after processing this one will be here dog. This is at the level 4. And also we have this one log. This is also at the level 4. So we have here dog and log, right? So in the example, we have dog and log. We have checked this one. Now the queue after processing in the level 3 will be this one, dog 4 and log 4. Now we have to process dog and log that is present in the level 3 for level 4. Let's move on with the level 4. So now what we are doing, we have to process dog and log that is present at the previous step. Let's process this one. So here dog, just give me a second. Yeah, we have to process dog and log, right? So dog here, this can be processed to cog directly. In this case, here we have dog. This one, dog, this can be processed to cog directly in this case here. This one, dog can be processed to cog directly, right? So let me come here. So this is valid because here only one letter, this one C is replaced by D in this case, right? So valid reaches the end word here. Valid reaches the end word. So now we have to stop the BFS, right? So we stop and return the 5. We'll return 5 because the number of words in the sequence is 5 in this case, right? So here, 4th level, this one now, the queue contains the level 5, right? Queue will be here in this case. You can clearly see dog, comma, 5 here, right? Cog, comma, 5 here in this case, right? So here in the level 1, you can clearly see the first level was this one. What do you call? Sorry, I'll just come here. Yeah, the first level was here, this one, hot. We will consider this one. Final output, we'll consider hot, the first one, the level 1. And the second level we got here is, let's move on with the second level. Here, hot. So hit was the first level and hot was the second one. So similarly, we'll go level by level, right? So the third level, let's move on with the level 3 here very quickly. So I'll just come here. So level 3 right here. So you can clearly see we have dog and log. We'll consider the first one itself here. So did I, yeah, dog and this one. Third one, level 2 we have considered already, right? The level 2 we were having this one, dot and lot. So we have 5 this one here. So just give me a second here. So yeah, from level 3 we'll be considering dot. So from the level 4 we'll be considering this one, dog. So finally the level 5, this one we will considering cog, and this is the shortest, this one, sequence to reach from begin word to end word in the word set, right? So then we will finally return the last one. return the length of the sequence as output 5. So this is the approach that we will be going with. I hope the approach is completely clear. As we are going level by level, we'll be making use of the this one BFS. We saw that one, and also at for the sequence, in the sequence every word differs by one letter, so we'll be going with the hash set. That is the reason we went with BFS with hash set approach, right? I hope this is completely clear approach. Let's discuss the edge cases one by one. So I'll just come here. Let's discuss the edge cases here. So the first edge case that I'll be going with here is word list does not contain end word. So word list doesn't contain end word here. This is fine. This is the condition that we are going with here. So input, let me give here begin word. I'll just take BW. Begin word, let me consider hit itself, and end word, let me consider here cog. So the example one itself, right? They have clearly mentioned in the question. So end word cog. So word list WL, let me consider here hot and cog. Cog should not be present, right? Hot dot, let me consider this one. This is enough. So word list is not present in the this one at all. The end word is not present in the word list at all. In that case, output we need to return 0. That's what they have given in the question. The output will be 0. This is for the condition word list does not contain end word. Let's move on with the second, this one, edge case. No valid transformation sequence exists. So here, this is for the condition no valid transformation sequence exist. So this is fine. So begin word, let me consider here triple A. So end word, let me consider here triple B. In this case, this is fine. So word list also we should be having the word list as well here. If we have triple A and ABB. So here we are not having the end word that is present in end word is not present in the word list. So again we have to return 0. This is for no valid transformation sequence at all, right? So I hope the second one is clear. Second edge case is clear. Let's move on with the third edge case. Nothing but here third or the final edge case, shortest path. Shortest path is direct. When I say shortest path is direct, it is nothing but only one change that is needed. In this case, begin word, let me consider here hot, and end word, let me consider here dot. This is fine. And the final one, word list, let me consider here dot. So we have only dot here. This shortest path is the direct. This is what the condition we are going with, right? So we have only one word, dot dot, right? So hot and dot. So output will be here hot dot. So this will be at the level 1, this will be at the level 2. So the output we need to return here is 2, right? I hope this is clear. The first edge case that we went with here is word list does not contain end word. The second edge case that we went with here is no valid transformation sequence exists. And the third edge case that we went with here is shortest path is direct. I hope all the edge cases are clear here. Next, let's start writing the code. So let's start writing the code. As we discussed in the approach, let's create a queue for BFS where each entry stores the current word and the transformation count word and the this one level, right? So for that one, we'll be making use of the queue here. Same I had explained in the approach as well. So let me quickly write here. Begin word. This is word. Begin word we have to consider and its level initially, right? So we are just creating the queue for BFS where each entry is stored. The second step is we have to convert the word list into the set for the big O of 1 lookups, right? So word set, this we saw same thing. Every word differs in the word list, right? Every single word returns this one differs, and it is first because we are converting word list into a set for the big of 1 lookups. So I can just write this one in this way, new set of word list. So this is fine. Next step, if end word is this edge case we saw, and this we saw in the approach as well, in the second example as well, sorry. So if the end word is not in the word set at all, we have to return 0. They have clearly mentioned in the question. If end word is not present in the word set, then we have to 0, right? Return 0. So no transformation is possible at all if the end word is not present in the word set, right? So this is simple if condition. If not of word, so I'll just give your word set dot has. I'm making use of the property has of the this one hash set here. End word, then they will return 0. So this is fine. Next thing, what we are doing, we have to start the BFS traversal. We were performing the BFS in the approach, right, in the step 2. So let's go with the BFS traversal while of this one, length of the queue. So what we'll do here, first we have to extract the front of the queue, right? So queue is having the property front and rear. So we'll be making use of the front here. So we have to extract the front of the queue. To extract the front, we can just go with the front, or we can go with the shift as well. We have the shift, right? Shift property. So I'll just come here, word, comma, level, this one, queue. I'll just go with the shift. This is fine. So the next step, we have to iterate through the each character of the word and convert to the array for the mutation, right? So let's do that. Let's iterate through the each character of the word. So I'll just make use of the for loop here. I equals 0 less than length of the word, and let's increment the I here. This is fine. Let's convert to array for the mutation. So here word array. From the word set to array we have to consider here, right? So I'll just give here word split. This is just for the mutation purpose. We are converting to array. So let me make use of the split property here. We need individual letters, right? We're splitting this one to the individual letters. This is fine. Sorry. So I hope this step is completely clear. We were just iterating through the each character of the word. Then we converted that one to the array just for the mutation purpose. Next, let's try replacing the character with every letter from A to Z. I'll just consider the char code from 97 to 123 because the small letter A starts at this one, 97, and Z or the Z starts at 123. So I'll just consider from 97 to 123. What we are doing here, we are replacing the character with every letter from A to Z. So I'll just come here. I'll make use of the for. Let me make use of char code itself. 97 char code less than 123. Let me give here char code. Let's increment the char code here. This is fine. The next step, let me consider here word array, iterated value of the word array. So this one, let's convert to string from, we'll be making use of from char code here. From char code, this one. Let me copy this one. Paste it over here. Hope this is clear. We are just replacing the character with every letter from A to Z. So I hope this is clear. Next step is we are just converting back that one to the string. Now we have made use of the from char code right here. So let's convert back to the string. I'll just consider here new word. Let me give here word array dot join. So we are converting back to the string. I hope this is clear till here. Next step, if new word is in the word set, then we have to process it. Only if the new word is in the word set, then we have to process it, right? Simple if condition. Let me go with the word set. So let me copy this one. Word set. New word is present in the word set. I'm just making use of the hash, the property of the hash set. If you don't know the properties of the hash set, please do Google or please do go through the JavaScript playlist of mine. So I have explained that one clearly by considering the examples, right? So it will be easier to understand while I write the code by making use of hash set or the hash map. If you go through those videos, right? So if we found the end word, then we have to return the transformation count here. So nothing but level plus 1, right? So if we have found the end word, new words, this one equals end word, then what we will do? We have to return level plus 1 in this case. So if we have found the end word, we have to return the transformation count. So I hope this is clear. Next step is, let's push the new word into the queue and remove it from the set. So after we have found the end word, what we have to do? We have to push the new word into the queue and remove it from the set, right? So I'll just give here queue dot push new word level plus 1. This is fine. Word set means we are removing it from the set. To remove the word from the set, we'll be making use of the delete property. So I'll just give you a new word. So this is fine. What we are doing here, we are just pushing the new word or adding the new word into the queue, and we are removing it from the set. That's what we saw while we considered the first example in the approach. That's what we saw step by step, right? So this is it for the code. The final step is here. If no transformation sequence is found, then we have to return 0. Means if no transformation, this one sequence is found here, or if the end word is not present at all, that condition we have already written here. If the end word is not present at all in the word list, then we have to return 0. And here, after performing the BFS, if no transformation sequence is found, then we have to return 0 at that case as well. So I'll just give here return 0. So this is it for the this one code. Let me hit the run button. So here N word I have misspelled here, and let me add the D. Let me hit the run button again. So I hope this works, man. Again, word array is not defined. Line number 16. Let's see what is wrong here. Word array we have considered here, right? What is wrong? So here you can clearly see word array we have defined, but bracket. So this one bracket I have to place here at the end. Misplacing the bracket. So I have misplaced the brackets, right? So this is fine. Now let me hit the run button. So I hope this works now. Wrong answer. So what I have done here is, here in the line number 18, if the word set dot has new word, right? We have assigned this one to the new word, and we have to check for the new word here, whether we are having the new word or not. So here this has to be new word. So I have just given the word here. So let me hit the run button now. I hope this works this time. So yeah, you can clearly see the sample test cases are getting passed. So let me hit the submit button. Some typos. Anyway, that's fine. So yeah, you can clearly see here all the test cases are getting passed here. So the code works absolutely correct, right? So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is BFS. We know that. And what would be the time complexity here? The overall time complexity would be big O of m into n. So m here is nothing but the length of each word. Maximum length of the each word would be 10. So that's what they have mentioned in the constraints as well, right? here, this one. M is nothing but the length of each word, and N is nothing but the number of words in the word list. Maximum they have mentioned here as 5000 here. M is nothing but the length of each word, N is nothing but the number of words in the word list, and each word has M positions. For each position, we attempt 26 changes because it can be from A to Z here. This step you can clearly see. The char code we have considered from 96 to 123 here. 97 to 123. 97 means small letter A, 123 means small letter Z, right? So each word has M positions, and for each position, we attempt 26 changes. This one we have to keep in mind, and BFS processes each word big O of M into 26, and in the worst case we can process, or we have to process all the N words, right? So that is the reason the time complexity would be here big O of M into N. So what would be the space complexity here? The space complexity would be here big O of N. Why the space complexity here is big O of N, not the big O of M into N? Because Q can store up to N words, and the word set here, word set here we have considered here, right? Word set, this one, the word set contains up to N words, right? And the queue can store up to all the N words, right? In the worst case. So that is the reason the space complexity would be big of N here. So the time complexity would be big of M into N, and the space complexity would be big of N. I hope the code that we have written, or I hope the solution is completely clear. Whatever the code that we have written is completely clear, and the solution is completely clear as well, right? For now, this is it. Thanks for watching, guys.